Welcome to our deep dive today. You shared a really thought-provoking research paper with us titled Back to Basics, Revisiting Reinforced Style Optimization for Learning from Human Feedback in LLMs. As someone, deeply familiar with machine learning, data science, and mathematics,
Right.
I'm sure you're as curious as I am to kind of unpack this.
Absolutely. The title itself is very intriguing. It
Yeah.
hints at a potential shift in how we think about aligning large language models,
Yeah.
especially with the increasing popularity of RLHF,
Yeah.
or reinforcement learning from human feedback.
Exactly. And this paper really throws down the gauntlet, suggesting that simpler might be better
Yeah.
than these, complex algorithms like PPO when it comes to the RL part of RLHF for LLMs.
Right.
So let's dive into their arguments and see why they believe reinforce might be the unsung hero we've overlooked.
Okay, so a key argument that they present revolves around PPO's computational cost
Okay.
and the inherent nature of pre-trained LLMs.
Mm.
PPO, while effective in many RL settings, demands significant resources
Right.
and careful parameter tuning.
Yeah.
The authors argue that the issues PPO was designed to address, like wild policy updates, are less prominent in LLMs that already have a strong foundation from pre-training.
That's interesting because it challenges a common assumption. We often gravitate towards more complex solutions,
Right.
but this paper prompts us to question if that complexity is truly necessary
Yeah.
in the context of LLMs.
Precisely. They delve into the classic bias variance trade-off,
Yeah.
highlighting that while PPO aims to minimize variance,
Okay.
in policy updates it potentially introduces bias.
Right.
And in the case of already well-trained LLMs, this bias might outweigh the benefits of reduced variance.
So they're suggesting that the inherent stability of pre-trained LLMs
Yeah.
allows for a more direct optimization approach,
Yeah.
leading them back to the classic reinforce algorithm.
Yes, and they don't just stop at the basic reinforce. They introduce RLO,
Okay.
or reinforce leave one out, a multi-sample variant, designed to further mitigate variance while using data more efficiently than methods like RFT, which often focus solely on the top-ranked sample.
This seems to tie into another interesting point they raise about how we conceptualize actions
Yeah.
in RLHF.
Right.
While PPO treats each generated token as a separate action, the paper argues for viewing the entire generated sequence as a single action.
Right.
This shift in perspective aligns well with using reinforce and RLU, which are adept at handling longer sequences.
That's an insightful observation.
Yeah.
They're essentially advocating for a more holistic approach to optimization,
Yeah.
aligning with the fact that human feedback typically evaluates the entire not individual tokens.
And this holistic view seems to pay off in their results.
Yeah.
They found that RLO consistently outperformed other methods in terms of both reward and win rates against human-evaluated references, achieving strong performance with fewer samples.
It's worth noting that they also address the concern of the alignment tax, where aligning models can sometimes hurt fluency or diversity.
Yeah.
They found no significant alignment tax with RLO or the other methods they tested,
Okay.
suggesting we can achieve alignment without sacrificing those qualities.
This leads us to a very intriguing question. If simpler methods like reinforce,
Right.
particularly in its multi-sample RLO form, are proving effective and efficient, does this change how we approach future LLM development?
That's a question with far-reaching implications, perhaps revisiting and refining these fundamental algorithms.
Right.
Adapting them specifically for LLMs holds more potential than solely pursuing increasingly complex solutions.
It's a call to carefully consider the problem's nuances and choose the right tool for the job, even if it means going back to basics.
Right.
Now, to really understand the weight of their claims, let's take a closer look at the data sets and models they use in their experiments.
Okay. Their choice of data sets is key to understanding the scope of their findings.
Right.
They focus on two well-established benchmarks in LLM alignment. The TLDR summarized data set, which emphasizes generating concise and informative summaries,
Okay.
and the Anthropic Helpful and Harmless Dialogue dataset, also known as HH,
Right.
focused on training models for safe and helpful conversational responses.
Both data sets are heavily reliant on human preference judgments,
Yeah.
which is essential for training the reward models used in RLHF,
Right.
and for ultimately evaluating how well these models align with what we humans want.
Exactly.
Yeah.
So They primarily use the Pythia 6.9b model for both datasets,
Okay.
ensuring a strong baseline for comparing the different RLHF methods.
Okay.
But to further assess the generalizability of their findings, they also conducted experiments with the Llama 7b model on the HH dataset.
And this is where it gets interesting. Observing consistent results across both models strengthens their argument.
Right.
That RLO's effectiveness isn't tied to a specific model architecture.
Yeah.
It suggests a potential broader applicability, which is quite exciting.
To assess performance, they didn't just rely on the intrinsic objective of maximizing reward.
Yeah.
From the reward model, they went further, employing simulated win rates based on the alpaca farm framework.
Okay.
Using GPT-4 as a proxy for human evaluation.
Right.
To judge model outputs against reference outputs.
This approach allows for a more scalable and efficient way to gauge alignment with human preferences.
Right.
Without requiring extensive human annotations
Yeah.
for each model and dataset combination.
They were also meticulous in considering the potential impact of RLHF on language fluency and diversity.
Okay.
They measured perplexity as an indicator of fluency.
Right.
And average anagram diversity to assess the range of language used in the outputs.
This comprehensive approach allowed them to capture a holistic view of the model's performance.
Yeah.
Ensuring that alignment with human preferences didn't come at the cost of other desirable language qualities.
Now, the results themselves paint a compelling picture.
Yeah.
Their findings support their hypothesis that treating the entire generated sequence as a single action
As reinforce and RLO do, is more effective than the token-level approach of PPO or vanilla policy gradient.
even without the multi-sample variance reduction of RLOO,
Right.
the basic reinforce with a simple moving average baseline performed on par with vanilla PG
Yeah.
in terms of win rates on both datasets.
But when they incorporated the multi-sample mechanism of RLO,
Okay.
the results became even more pronounced.
Yeah.
RLO consistently outperformed RLT,
Mm-hmm.
showcasing the effectiveness of utilizing all samples for baseline construction and gradient calculation.
And importantly, RLO achieved these results with greater sample efficiency than RLFT,
Right?
requiring fewer samples for comparable or better performance.
Yeah.
This has significant implications for computational costs, especially when working with large language models.
The comparison with PPO, which has been a mainstay in RLHF, is particularly striking.
Right.
RLO, with its multi-sample approach, delivered significant win rate improvements over PPO
Yeah.
across both datasets and models, often exceeding 10 percentage points. These findings directly challenge the assumption that more complex algorithms are inherently better.
Right.
The simplicity and efficiency of RLO, coupled with its strong performance,
Yeah.
suggest a potential paradigm shift in how we approach RLHF for LLMs.
The lack of a significant alignment tax with any of the methods tested, including RLOO, further strengthens their argument.
Right.
It demonstrates that aligning these models with human preferences doesn't have to come at the expense of fluent and diverse language generation.
This research presents a compelling case for revisiting and refining fundamental RO algorithms
Right.
like reinforce, adapting them specifically for the unique characteristics of LLMs.
Right.
The efficiency, performance, and lack of alignment tax observed with RLO point towards a promising direction for future development. It's crucial to acknowledge this is just one study, right? And
Yeah.
further research is needed to really validate these findings and explore their generalizability across a wider range of models, data sets, and tasks.
Absolutely. While the results are promising, we should approach them with a healthy dose of scientific skepticism.
Yeah.
The field of LLM alignment is constantly evolving, with new approaches emerging all the time.
Yeah.
This paper contributes a valuable perspective to this ongoing conversation, challenging assumptions
Right.
and opening up new avenues for exploration.
Their findings raise a crucial question. If simpler methods like reinforce,
Yeah.
particularly its multi-sample variant RLOO,
Uh-huh.
prove consistently effective and efficient, could this signal a shift
Right.
in how we approach LLM development in the future?
It certainly invites us to reconsider our assumptions about the necessity of ever-increasing complexity in our algorithms.
Yeah.
Perhaps there's a wealth of untapped potential in revisiting and refining these foundational techniques, adapting them specifically to the nuances of working with large language models.
This research reminds us that innovation isn't always about adding more layers of complexity.
Right.
Sometimes it's about deeply understanding the problem and finding elegant, efficient solutions.
Yeah.
Even if it means going back to basics.
A big thank you to you, our listener, for sharing this thought-provoking research paper with us.
Yes, thank you so much for listening.
It sparked a fascinating discussion and challenged us to rethink some of our own assumptions.
Absolutely. And we encourage all our listeners to delve into the full paper for a more comprehensive understanding of their methodology and results. This is just the tip of the iceberg when it comes to aligning large language models with human preferences.
Right.
And there's much more to explore and discover. Until next time, keep those brilliant minds engaged, and we'll see you on our next deep dive.